Hello everyone and welcome to Say It with Symbols 3.3. Our learning target today is we'll be able to solve linear and quadratic equations and begin to explore systems of those equations. 3.3 ACEs will be 24 through 26, 46 through 48, and 57 and 58. We begin today on page 50 with 3.3, factoring quadratic equations. We get to go back to dealing with these quadratic equations, and for those of you that went through frogs, fleas, and painted cubes, you well off to a good start here. We're just going to build on some of the lessons we learned there, get some practice, and improve on our factoring of quadratic equations. So it tells us here sometimes mathematical problems that appear to be different are actually the same. Finding the x-intercepts of the graph y equals x squared plus 5x, right here, is the same as solving the equation x squared plus 5x equals 0. And ways we can show you that we have the x squared plus 5x. We also have our table over here that shows our x-intercept of -5 and our x-intercept of 0. You can see here there's an x-intercept of -5 and an x-intercept of 0. If we want to look at solving this equation, we have our x squared, okay, plus, remember again, I'm writing this offhanded, so it's going to look weird. Anyway, x squared plus 5x equals 0. Well, we want to factor out our greatest common factor. Well, the only thing that we have that's the same here are the x's. So we would have x times x plus 5, okay, and this equals 0. Well, this gives us two equations that equal 0. Now, we would need to break these two up. So we have, take one, we take our x, set it equal to 0, okay, and then we take our other product and take x plus 5 equals 0. And to solve for x, we need to subtract 5 from both sides, okay, both sides. So we get x equals -5, okay? So if we look here, we have x equals 0 and x equals -5. Well, look, x equals 0, x equals -5, x equals 0, x equals -5. So we solved for this, and by factoring it out, we found our x-intercepts. These are also called the roots of the equation, okay? 0 and -5 would be the roots of the equation. I'm going to skip ahead here and jump to part B of Say It with Symbols. And it asks us to use a method similar to Jakai's to write each expression in factored form. I don't really care about Jakai. I want us to write each expression in factored form and show why each factored form is correct, which means check it, prove it that it will work. So I have some steps for you down here that when we are factoring, we want to factor out our greatest common factor, see if it fits a pattern. Then if no coefficient of x squared, and none of these have a coefficient of x squared, it's all one. On part C, you'll have an area for B and C, both of them that have coefficients of x squared. We'll get to that later. But if no coefficients of x squared, which two factors add and multiply to get b and c? Remember, this is ax squared, okay, plus bx plus c. I would encourage you to get out your notes from frog, fleas, and painted cubes because we're just building on everything we had there. So go ahead and open those up. So we need to find factors of 4 that when multiplied together become 4, and when added together would become 5 here, because our number is positive here. We know that when this number is positive, that both of the signs are going to be the same in for our B term. So options for factoring with 4 are 1 and 4, or 2 and 2. Well, we need to be able to add numbers together to equal 5. Well, 1 plus 4 equals 5, okay, and 2 plus 2 equals 4. So we are going to need to use the factor 1 and 4 to write out our equation. So to factor this out, then we're going to have two sets of parentheses, okay, and we'll have x for each one, and then because this is a positive and this is a positive, both of these are also going to be positives, and we'll put 4 in one of them and 1 in one of them. So there's 1 and there's 4. Now, this is now factored, okay? It equals 0, or you can have it equal y. But then if we wanted to find our x-intercept value, we would have to set each of these equal to 0. So we would have x plus 1 equals 0, and different color, x plus 4 equals 0. We need to solve for x, so here we would subtract 4 from both sides, and we would get x equals -4. And over here, we need to subtract 1 from each side, and so we would get x equals -1. So your two x-intercepts for this equation would be x equals -1 and x equals -4. Again, those are also the roots for those. So do that for the rest of part B. And then on part C, factors are a little different. We don't have ax squared plus bx plus c. Sometimes we just have ax squared plus bx with no c. And sometimes we have ax squared plus c with no bx. So we're using these steps and your notes from Frogs, Fleas, and Painted Cubes. Go ahead and start factoring these, doing the best you can, and I look forward to your comments and questions in class. Again, ACEs for this problem will be 24 through 26, 46 through 48, and 57 and 58. Thank you.